All right, so there are this video is going to go over selection structures and decision making, how that's done in programming. Um, so there are three main structures. There's three main structures in all programs. There's the sequence, there's the selection, and there's the iteration. So sequence structures are just any statement. And in programming, they end up forming an algorithm. Selection is how decisions are made. And in C++, they're mainly used if and else statements. Now there's also the switch case. And I've actually, I know how to use them, and but like professionally, when I was a programmer, I never used a switch case statement. Everything is just kind of if else. Even though switch cases are supposed to be faster. Iteration. Those are loops. Okay. So this chapter and this video is going to go over selection statements. Okay. So let's see if there's like a clear button, or do I have to just restart new? Now, let's see. Alright, I'll just close that. Alright, so I'll just make a new one. Alright. So let's say we've got an int age variable, and I don't know, my age is 41. So we could have an if statement. If age is greater than or equal to 21, C out. Now I could do this. I could say C out. You can go to bars. Okay. Else. Sorry, I'm trying to draw like a. Else. See out. You can go home. So, in my case, I can go to bars even though I haven't been to a bar in years. But if your age is not greater than or equal to 21, this is what's going to display, alright? So, that's just your basic if-else structure, alright? But there's more that you can do with it. Let's do this. Let's look at this. So there's more things you can do if you're 21, right? You can go to bars. You can vote. And let's say you can drive. Okay. So else if let's say age is greater than or equal to 18, you can see out, you can vote, and you can drive. Could have another else if age is greater than or equal to 16, and you could say see out, you can drive. Finally else, see out, I don't know, you are an infant. All right, so that would be a good, selection structure, checking on, their age and the different things that they could do that would print depending on the person's age. In my case, all three of those would print, but if you're 19 or 20 or 18, you'd have these two print. Okay, so one thing to notice, you always want to tab these, everything inside an if statement you want to tab over once, and ideally you're working with, so white space is like if you're programming in Python, there are no opening and closing braces like I have here and here. Like this closes this if statement. So in Python, the white space actually determines what's inside an if statement or whatever. But what you do with the older programming languages is that you tab things over, and it won't create an error, but it's hard to read. So ideally, everything lines up with our eye, so that would go down, and we could see where the if statement starts and ends, where the else if starts and ends, where it starts and ends. Okay. So that's white space. Let me see here. Is there just like a delete on this thing? I mean, I guess I could try just. Alright, so that's that example. So, you know what? That takes too long. I'm just going to close that. I'm going to close this one. I'm going to open up a new one. Alright, so we've got, now I went through the arithmetic operators a couple videos ago with like the plus, minus, multiply, division, and modulus symbol, and then the combination or combined operators, but these are going to be your logical operators. Okay, so first up, you got the double ampersand. This means and or both. Okay, and I kind of am starting to like the word both more than and. I'll go through that later on. These are your pipes. And the pipes are, if you press shift and then the button above your enter button, they're just straight lines. This is or. One or the other. And I'll go through examples in a little bit. And that's not. Okay, so those are your three logical operators, all right? So I went through what a Boolean stored, or a bool. That's the data type bool, but it's a Boolean, and it can only hold the word true or the word false. Okay, something's true or false. So this sets us up nicely for something called truth tables. Truth tables. Okay, so let's say we've got our variables A, and we got a variable B. We got A and B. So A, now these are just the values that A or B could be equal to. A could be true, and I'm going to put just T because, again, writing with these are hard. So true or B can be true. A could be true, B could be false. A could be false, B could be true. A could be false, B could be false. So what does this evaluate to? So if you got true and true, so and this is why I like the word both on these. Are both of these true? Yes. So it evaluates to true. Okay. Then you got true and false. Do both of these evaluate to true? No. This one right here is false. So are they both true? No. So the whole statement is false. Okay. Then next up you got false and true. Are they both true? Nope. So the whole thing's false. And then finally you got false and false. Are they both true? Nope. So the whole thing's false. So true and true is true, true and false is false, false and true is false, false and false is false. Okay. So this is the logical truth table for ands. Okay. Then we could do ors. And this is why I like one or the other. Okay, so we can have true, 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 false, false, true, false, false. So true or true. Is one or the other true? Yep, that one's true, so the whole thing is true. Now, what I just went through is something called short-circuiting. Since only one of these has to be true, it read that one, so it just assumes it doesn't care whether this one's true or false. It just, this one's true, so the whole thing's true. Short-circuiting would occur on this one and this one as well, where the first one's false, so it doesn't even, since they both have to be true, if the first one's false, it doesn't matter whether the second one's true or false. But like for these ones, you still have to run them because you have to see if the second one's going to be true. In this case it was, in this case it wasn't. Okay, so then again you've got short-circuiting going here. True or false. Is one or the other of these true? Yep, the first one is, so the whole thing is true. You got false or true. This one is true, one or the other is true, so the whole thing is true. And then finally you got false or false. They're both false. One or the other is not true, so the whole thing is false. Okay, so that is that's truth tables. Okay, and you'll definitely have them. I don't know about memorize them, but just better to understand the concept. And I'll go through some sample questions here in a minute. All right, so how do these truth tables, why do they matter? What are you doing them for? Let's say we had three numbers, okay, and they were all int. So int num1, num2, num3. Okay. And let's say we wanted to determine the largest number of these. Okay. So in our mind, whatever these numbers are in our mind, we could pick through and just boom, that one's the largest one, and we won't even think about how we got to that process. But this is how you would actually do it if you slow your brain down. If num1 is greater than, now I'm not going to worry about them being equal because that would change this example up, and I'm not going to deal with that now. But just go with the flow here. Just assume that these numbers aren't equal. So is num1 greater than num2? And because I have to check it to this one, and I've got to check it against that one. And is num1 greater than num3? So this is where your Boolean, your logical operator comes in. If that is, let's say this is 10 and this is 8 and this is 7. Is 10 greater than 8? Yep, that's true. And is 10 greater than 3? That's true as well. So then you'd have like a cout num1 is largest. Okay. Else if, and this is where you do, is num2 greater than num1, and is num2 greater than num3? If both of those true, then cout num2 is the largest. Else, now we only have 3 numbers, so either num1 is the largest, num2 is the largest, or cout num3 is the largest. Okay. And when you've got these else if statements, your last statement else should be, some sort of, you don't have to check the condition. It should just be like the last thing that the selection structure could possibly be, and then just, print it out or do whatever you're going to do with that. Okay. So that's that. Another thing we want to talk about is the equal sign. So this is equals. Okay, and even as a matter of fact, you know what? I don't even like it to be called equals, even though I will do that, and we all do that. I don't know, A is equal to 5. Okay, but really it should be considered. It's assigning it to 5. It's assigning A to 5, all right? And the reason why we get this, why this becomes an issue, is because you have the equal symbol and the equals symbol, all right? And the equal symbol checks for equality. Okay? So let's say we have B equals 5, all right? So if I did if A is equal to, now let's check this out. If A equals B, if that's true, which it is, then cout A is equivalent to B. Okay, and assume that's all on one line, all right? But this would actually give you an error, because again, this is assigning. You can't assign information inside a Boolean condition, okay? So that gives you an error, all right? Error. So you need to make sure you're using double equal symbols to check for equality, all right? Because again, You know, if statements in the Boolean conditions need to come out as true or false, and assigning A to B isn't a true or false, and so it screws up the compiler. All right, so that's that. And so I think maybe the best way to end this is to work some problems. Okay. So, and let's open this up. Now, if you guys want me to send this worksheet, we can, but I think it's just best just to watch it and see what I'm doing. So A is 28, B is 47, C is 84. Now, again, this is from my Java class. So when you see this, this is just a C out. All it's doing is C out. And then hello. Okay. So the point is, it's not whether you understand this, is can you read through these if-else statements. Now, Java was built off of C++, so a lot of the code looks very similar, okay? There are some differences that I'm not going to talk about because that's not the point, but, you know, is 28 less than 30? That's true. And then is 84 greater than or equal to? So you got true and false. So are they both true? Nope. So then we got to check this else statement. Okay, else if, and again, I don't like how this is written out at all, but you got to work with what you got. Okay, so it's just, you know, making sure you can read through this. Is B, which is 47 greater than 50? No, but we've got an or statement, so this is false. And then we got or is A, which is 28. Is 28 greater than 25? Yes, it is. So you got false or true. Is one or the other true? Yes, this is true. So it would print goodbye to the screen. And that's your answer. Okay. Next up, and then when you see the word Boolean, in Java, they spell out the entire word to for their data type, where C++ just does the word bool. Okay, so Boolean 1, 2, 3. 1 is true, 2 is false, 3 is true. So remember that the exclamation point is not. So 1 is true. So if something's not true, it is false. Okay. And you got an or statement, false or false. Okay, that's false, so we won't do that. Else if we have true and 3 is true, so not true, so you got true and false, so that's false. And so the last one you have is just that one, so that's what prints. We'll do the last two on this page. So we got pockets 5, bucks need is 20, late is false. So late is false. If it's late, which is false, it's not. Or so is the pocket. So you got false. Or and then is 5 less than, but is 5. So 5 less than 20. That's true. So it's false, or, and then 5 is less than 20. That's true. Is one or the other true? Yes. So it's let's go home. And then finally we got Jill is 6, hours is 5. Is 6 less than 5? Nope, that's false. So then it's that right there. Okay. Now these are the kind of questions my AP kids will get on their AP tests. So I can kind of go through them real quick. So remember the Boolean expression A or B and B is true, and then you'd have to do the multiple choice. So you'd have to fill out your truth table. True, 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 false, false, true, false, false. So true or true is one or the other true. Yep, so this whole thing is true. True or false is one or the other true. Yep. False or true is one or the other true. Yep. And false or false is false. So that takes, so this right here takes care of that. And so then we have this side. So we have true, 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 and false. And again, that's just this part. And then we've got our and then B right here is true. So true and true is true. And then F is false. B is false. In this case, B is true. And in this case, B is false. So false and false is false and true and false is false. True and true is true. And then finally, false and false is false. Okay. And then again, you would just do this. True, 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 false, false, true, false, false. So are they both? You got the and. Are they both true? Yep. So this whole thing's true. Are they both true? Nope, that's false. Are they both true? Nope, that's false. Are they both true? Nope, that's false. Okay. So you got true, false, false, false. You got ors. And then A in this case is true, true, false, false. So true or true is true. False or true is true. False or false is false. And false is false. Okay. And this last one real quick. And this video is almost done, so just bear with me a little bit longer. So you got true, 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 false, false, true, false, false. And that's, I don't want to get that mixed up, so that's a false. Okay, so true and true is true. True and false is false. False and true is false. False and false is false. So you got true, false, false, false. And A is true. And. So A is true, false, false. So true and true is true. False and true is false and true is false, false, false. And to be honest, I screwed up because I should have picked the multiple choice. But once you get this, the multiple choice is easy. So the Boolean expression, whenever A is true, in this case, if you look at these, the only time it comes out to be true is when both A and B are true. So the answer for this one's D. So because the other ones, whenever B is true, well, B is true in this case, but it's also true in this case. This one ends up being true, and this one ends up being false. And the only reason this one is true is because A is true as well as B. So that's kind of how you work through them. You could go back and watch this and pick A, B, C, or D, E. I don't remember the answer to all of these, so I'd have to rewrite them all. But again, you could pick the answer based on it. It's not that hard to do once you fill out the truth table. So that's that. I think there was one other thing I had. Yeah, this one right here. So you would never want to code like this, It says, warning, this code contains errors. Now, the way that an if and else statement works, if you don't have braces, okay, then what happens is this statement right here belongs to this if statement, okay? If this is true, it only is required to run this first statement, okay? It would then run these two statements as if they were not part of the if, okay? So, but it would run all three of these in this case. But because this one and this one aren't considered part of this if statement, it would hit an else, and it would say something on the lines of else with no matching if statement. Okay? So in order to fix that, if you want all three of these to be together and have an else statement that goes along with this match, this if, you'd have to have opening braces here, and then a closing brace there, and then opening brace on that, and a closing brace on that, okay? Indenting doesn't do anything in C++, so you have to break up. And I always tell young students, always have an opening brace after the Boolean condition and to end the if or else statement. That makes it easier to that's just a good rule of thumb. Have your braces opening and close your if else structure. So anyway, that's it for this video. So this video is done.